Hello and welcome back to this channel. Dear students, today's topic is periodic or non-periodic signals. We will be solving few numericals to check whether the signals are periodic or non-periodic. From the exam point of view, question is straightforward. Some equations will be given and it will be asked to check whether the signal is periodic or non-periodic. And it is also mentioned if signal is periodic, calculate the fundamental period. Dear students, I have already created some basic videos related to this subject. Actually, this topic is from the subject signals and systems for second year orientation students. So if you haven't yet watched those videos, do watch that videos, because in this subject everything is interlinked. You cannot simply pick up any topic and start studying. So do watch those videos. I would like to brush up the things what we have studied earlier related to periodic signal. If I will consider a standard diagram of a sine wave signal, then the graph is like this: x of t versus t. This is a standard sine wave. When we write x of t, notation t is there, it indicates it is CT signal, that is continuous time signal. Standard readings are, this is 0, this is pi, this is 2 pi. If I will extend this signal, let us say this signal is till infinity, then we are well aware that after this value, this is positive half cycle, this is negative half cycle. After this reading 2 pi, the signal repeats. Such signals are called as periodic signals. Mathematical equation is x of t is equals to x of t plus capital T. In this case, capital T is equals to 2 pi, because capital T indicates, or it is called as fundamental period. So after 2 pi, signal repeats. So capital T is 2 pi. This we have already studied. Same analogy, if I am talking about a discrete signal, then instead of notation T, use notation N. It represents, use notation N, it represents the discrete signal. The graph will be in the form of pulses. So similar diagram I will have to draw, but now this diagram will be in the form of pulses like this. If I will give some numbers, on this axis we are supposed to plot n, on this axis we are supposed to plot n. Such graph is known as DT signal, that is discrete time signal. Same sine wave, if I will draw it in the form of pulses, it is known as a discrete signal. On x axis, instead of t, I will have to mark n, and the numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8 and so on till infinity. Like in this case, the signal repeats after value 2 pi. Same analogy, after 8 numbers, signal repeats. This is called as the fundamental period. In CT signal, fundamental period is t is equals to 2 pi. Similar notation in DT signal is capital N. Very simple. Since we have replaced small t by small n, same way you have to replace capital T by capital N. So in this case, fundamental period will be 8 samples. Why the unit samples? Because in this case, after a particular number of samples, the signal repeats. So fundamental period is 8 samples. From the exam point of view, as I mentioned earlier, some equations will be given and it will be asked to check whether the signal is periodic or non-periodic. And if the signal is periodic, calculate the fundamental period. This is the standard question. I will tell you the simplest technique to solve the numerical. Strictly follow this method, so you will be in a position to solve any numerical. I have summarized the rules to solve this numerical. We will directly start the numerical. That time I will explain how to implement these rules. So, question, as I already mentioned, equations will be given and we have to check whether it is periodic or non-periodic. So first equation, suppose given equation is x of t is equals to cos square 2 pi t. Now, first we have to identify whether it is CT or DT signal. I have explained you in short the concept of CT or DT. Make it simple. Note, if notation T is there, it is known as CT signal. Remember it like this. If notation T is there, it is CT signal. If notation N is there, it is DT signal. CT means continuous time, DT means discrete time. So it is a CT signal. Then just observe whether it is a single term or there are addition of terms. It is a single term, no doubt, square is there, but it is a one term, then there are no addition of two terms. Now, since it is cos square, you have to make use of some mathematical identities. We have the standard mathematical formula, cos square theta is equals to 1 plus cos 2 theta upon 2. You would just simplify this equation because the term contains cos square. So I am using this trigonometric identity. In this case, theta means this bracket term, that is 2 pi t. So making use of this identity, I will write the given equation as 1 plus cos 2 theta. Theta is 2 pi t. So 2 into 2 pi t, it becomes 4 pi t divided by 2. It can be well written as 1/2 plus 1/2 cos 4 pi t. Now, don't get confused. There are two terms, but to check the periodicity, the signal must be in terms of sine or cosine. First term is 1/2, which is a constant term. Strictly and strictly, when you are solving numericals on periodicity, avoid constant term. Directly neglect constant term. It's of no use for periodicity. So consider that we have only this equation. Now, related to this equation, we have to write the standard formula. Make the thing simple. This is the cosine term. So related to this, standard formula can be written as a cos 2 pi f0t. This is a single term, only one term, so I am writing 2 pi f0t. If it would have been, if there would have been two terms, I would have written 2 pi f1t plus 2 pi f2t and so on. 1/2 is amplitude, it is denoted by a. Since there is a cos term, I have written cos, and every numerical, same technique is there, 2 pi ft. Whether it is f0, f1, f2, that is immaterial. If it would have been sine, I would have written sine. Fine. Now, this is the standard formula. We have this given equation. We are not interested in amplitude, so forget about amplitude. Consider this term only. So, if I will compare these two equations, I can write 2 pi f0t is equals to 4 pi t. f0 is known as fundamental frequency. Our interest is to calculate value of f0. So this pi gets cancelled, t gets cancelled. So f0 is 4 by 2. Therefore, t0. What is t0? See, f is the frequency, t is the time period. We have to calculate the fundamental time period. So I will have to take a reciprocal of this equation. So it is 2 by 4, which is same as 1 by 2. Now, look at the rules. So for CT term, single CT term, there was a single CT term. So I am using rule number 1. Calculate T0. T0 must be a rational number. What is a rational number? Meaning of word rational is ratio of two integers. For example, if I am getting 2 by 5, it is ratio of two integers, so it is a rational number. Same way, if I am getting 8 by 11, again it is ratio of two integers, so it is rational number. Instead of this, if I will get 8.1 divided by 11, something like this. So since decimal point is there, it is not rational, it is non-rational number. So what is the requirement? For single CT term, T0 must be rational. Look at the calculated answer. T0 is 1 by 2. There is no decimal point. So since it is rational, signal is periodic. In the exam, you will have to write it like this. Since T0 is rational, signal is periodic. What is its fundamental period? Simple. We have just now calculated value of T0. So whatever value of T0 we have, that is equals to 1/2 seconds is the fundamental period of this signal. So this is the way how to solve the numerical if there is single CT term. CT means continuous time signal term. Now let us solve one numerical related to discrete term. Suppose given equation is x of n is equals to cos of 8 pi n upon 15. This is the given equation. Again, this is the discrete signal, DT signal. How we identified? Since notation n is there, it is discrete signal. Same technique. There is no cos square term as such, so this is simple given equation. Related to this, first I would like to write the standard equation. So from the given equation itself, related to this, I will write standard equation as a cos 2 pi f0 n. Whatever it is in the bracket, standard equation is 2 pi fn. So since it is a single term, I have written 2 pi f0n. Now compare the bracket terms. So compare these two terms. So I can write it like this: 2 pi f0n is equals to 8 pi n upon 15. Now we have to calculate f0. This pi gets cancelled, n gets cancelled. So I will get f0, actually it becomes 2f0 is equals to 8 by 15. Therefore, f0 is equals to 8 by 30, which is same as 4 by 15. I have just simplified it. 8 by 30, I will divide numerator and denominator by 2. I got 4 by 15. Now, check the rule. For single dt term, f0 should be rational. Look at the calculated value of f0. It is 4 by 15. So, it is a rational number because it is ratio of two integers. Now, this is not the end of this numerical. It is a rational signal. So, we will conclude it is a periodic signal. But we need to calculate its fundamental period. How to calculate it? Since it is a discrete signal, do remember one word. Whatever value you got after doing calculation, so we got this value, f0 is 4 by 15. Equate this value or use this value related to notation as k by n. These are two simple notations. So k is 4, n is 15, n represents fundamental period. What I said, whatever calculated value you have, compare it with k by n indicates the fundamental period. So in this case, fundamental period n is equals to 15 samples. This is the way how to solve the single term of related to dt signal. Now to get more idea, we will solve some complicated numericals. The next question is x of t is 10 cos 12 pi t plus 4 sin 18 pi t. This equation, given equation, contains addition of two terms. So we have to use some different rules. Now, related to this, I have to first write the standard equation like this. X of t is, this is a cosine term. So I will write a cos in the bracket 2 pi f1 t. Why not f0? Why not y f1? Very simple. There are two terms. So I will be using f1, f2, f3 and so on. Plus, for second term, again same logic, a sine. Since it is sinusoidal term, sine wave, I am writing sine 2 pi f2 t. This sine and cos will not make any difference. Now, like the previous sum, compare these bracket terms. So, I will write 2 pi f1 t is equals to 12 pi t. For second term, again compare the bracket terms. So, for second term, I will get 2 pi f2 t is equals to 18 pi t. What is my aim? First, I need to calculate f1 and f2. f1 and f2 are frequencies. So, this t gets cancelled, pi gets cancelled. So, f1 is equals to 12 by 2, which is 6. Similarly, this pi t gets cancelled. f2 is equals to 18 by 2, which is equals to 9. So, I have done the calculation of f1 and f2. Now, let us refer the rule. So, we have addition of two terms. The given signal is a CT signal. How I identified? Notation is T. Very simple. So, notation T indicates it is a CT signal. So, I have to refer rule number 4. It is applicable for addition of two CT signals, that is x1 of t plus x2 of t. What is the rule? I need to calculate ratio T1 by T2. If it is rational, signal is periodic. Now, how to calculate T1 and T2? Keep in mind, the notation f in any signal represents frequency. If you take its reciprocal, so it is actually f is 1 by t, where t is the fundamental time period. Frequency and time period are reciprocal of each other. Now, to check the periodicity, I want to take ratio of t1 by t2. I have values of f1 by f1 and f2. How to calculate t1? T1 is simply reciprocal of f1. So, t1 is 1 by f1. So, I will directly write 1 by f1 is 1 by 6. Similarly, t2 is 1 by f2, reciprocal of this. It is 1 by 9. Now take the ratio T1 by T2. So it is 1 by 6 divided by 1 by 9. So it is simply 9 by 6. Again, if you simplify it, you don't have to solve this on the calculator. You just have to simplify it manually. So divide numerator and denominator by 3. So you will get 3 by 2. Now I can write it like this. T1 by T2 is equals to 3 by 2. Now check the rule. if T1 by T2 is a rational number, 3 by 2 is a rational number. What I got? T1 by T2 is equals to 3 by 2. 3 by 2 is a rational number, so signal is periodic. You will have to write the given signal is periodic because T1 by T2 ratio is the rational number. The question arises how to calculate fundamental frequency of entire signal. As I said, this is not the end of solution. So after this, I need to calculate fundamental period of the given signal. There are different rules, but strictly follow this method. It is the simplest method. How to do it? Once this part is completed, you will have to just mention signal is periodic. Next part is I need to calculate the fundamental period of total signal. How to do it? Take cross multiplication. So write it like this. The total fundamental period, I will write it like this. Total period or total fundamental period, capital T, is equals to, take cross multiplication, it is 2T1 or 3T2. Very simple. Total fundamental period is denoted by capital T. Take cross multiplication of earlier equation, it is either 2T1 or 3T2. 2T1 or 3T2. Now check the original values of T1 and T2. These are original values. These are simplified values. Don't treat like this. Don't take T1 as 3 and T2 as 2. No. Take original values. So original value of T1 is 1 by 6. Original value of T2 is 1 by 6. This answer you got after simplification. So you need to consider original values. Therefore, fundamental period is T is equals to 2 into 1 by 6 or 3 into 1 by 9. So in any case you will get 1 by 3. Here also you will get 1 by 3. So fundamental period is T is equals to 1 by 3, unit is second. So this is the simplest technique by which you can solve any numerical if it contains addition of two CT terms. Now let us solve one numerical which will contain addition of two discrete terms. Now consider the given equation x of n is 2 cos 5 pi n plus 3 sin 3 pi n by 4. This is the equation which is in the form of dt signal. How come? Because it contains the notation n and it is addition of two signals. Now, first of all, related to given equation, I need to write standard equation like a cos 2 pi f1n. Very simple. Earlier for CT signal we were using 2 pi f1t, 2 pi f2t. Instead of that, I am just using 2 pi f1n plus for second term I can write a sin 2 pi f2n. Similar to the earlier case, only difference is in place of t I am using n because in the given equation it contains notation n. Now like the previous case, compare the bracket terms. So I will have to compare these two terms. So 2 pi f1n is equals to 5 pi n upon 3. For second term, 2 pi f2n is equals to 3 pi n upon 4. Now we need to calculate f1 and f2. So pi n gets cancelled both sides. So I will get f1 is equals to 5 by 6. I have transferred this 2 at this side. So it is 5 by 6. Here again pi n gets cancelled. So I will get f2 is equals to 3 by 8. These two I have transferred at the RHS. So 3 by 8. Now in the earlier case what we did, it was a CT signal. So we took the reciprocal and we got T1 and T2. For DT, rules are different. If it is addition of two signals, take ratio of n1 by n2. It is not ratio of T1 by T2. Take ratio of n1 by n2. How to do it? Whatever values of f1 and f2 you have, use the standard notation. Write it like this: k1 by n1. Basic equation is f should be expressed as k by n. Since it is f1, write it as k1 by n1. Since it is f2, write it as k2 by n2. Now compare these terms. N1 is 6, N2 is 8. Therefore from this I can write N1 is 6. Here I can write N2 is equals to 8. Now take the ratio of N1 by N2. So if I will take the ratio of N1 by N2, I will get 6 by 8, which is same as divide numerator and denominator by 2. So I will get 3 by 4. As I mentioned earlier, don't do this calculation on the calculator. You have to do it manually. So our answer of n1 by n2 is equals to 3 by 4 after simplifying, after dividing numerator and denominator by 2. Now check the rule. N1 by n2, this ratio should be rational number. Rational means ratio of two integers. What's the ratio we got? 3 by 4. It is a rational number. It is ratio of two integers. So given signal is periodic. Now we have to also calculate its fundamental period. If signal is non-periodic, that will be the end of numerical. You don't have to do the calculation further. But if it is periodic, you need to calculate fundamental period of total signal. So how to do it? Like the previous case. Everything is similar now to the previous case. So fundamental period, I will write it over here. Fundamental period, that is capital N, is equals to, take cross multiplication. It is either 4n1, 4 into n1, or 3, this is n2, 3 into n2, which is same as 3n2. Therefore, fundamental period is 4 into n1. Now, take the original value of n1. Original value of n1 is 6. Original value of n2 is 6. Original means before simplifying it. So, it is 4 into 6, or fundamental period is, if you consider this term, 3 into 8 value of n2. So, in any case, you will get answer 24. Since this represents number of samples, fundamental period is n is equals to 24 samples. So this signal is again periodic and its fundamental period is 24 samples. If suppose, we haven't yet solved any numerical related to non-periodic signal. If suppose the equation is same and second term is only 3 pi n, how to do it? How would we would have solved it? Now listen. If I am considering this term as 3n by 4, this, let us say this is the given equation, first step remains same. In the second step, I will have to compare it like this. 2 pi f2n is equals to 3n by 4. So nn gets cancelled. f2 is equals to 3 by 8 pi. Very simple. This 2 pi I have transferred to the RHS side. So it becomes 3 by 8 pi. Now f2 can be expressed as k2 upon n2. So in this case n2 is 8 pi. Therefore n2 is equals to 8 pi. So if you take ratio of n1 and n2, then this ratio in this case n1 by n2 will become 6 by 8 pi, which is, if you divide numerator and denominator by 2, it becomes 3 by 4 pi. Do remember, this term contains pi. Pi is not 180 degree, it is rather 3.14. So it contains a decimal point. So this ratio is non-rational, non-integer, ratio of non-integer terms. So signal is non-periodic. So what I said, if given equation would have been like this, we would have done the calculation up to this step, and directly after this step you need to write signal is non-periodic. If signal is non-periodic, you don't have to calculate its fundamental period, because fundamental period is applicable for only periodic signal. So this is the way how you can solve any numerical. So if you just prepare these numericals and follow these methods, you will be in a position to solve any numerical. So dear students, that's it for today's session. Thank you. Thanks a lot.